Alright, today's video will go over graphs of functions. Pretty much the biggest test we have to tell if the graph of a relation is a function is by using what we call the vertical line test. The vertical line test, or VLT, you'll see me write that for shorthand, it just means that when a vertical line crosses through a graph more than once, it's not a function. So for these four examples, I know it can be kind of hard to read the equation, so part graph A is just the parent quadratic x squared. Question B is the parent cubic function. C is a sideways parabola, x equals y squared. And the fourth one is the circle with the radius of 1. Determine if the following four are functions. You notice for the first one, the quadratic, it passes the vertical line test, so that'd be yes. For the cubic, that would also be yes. But for the sideways parabola, if you notice, it fails the vertical line test at infinitely many points, so that'd be a no. Likewise for the circle. Now we can also determine other information such as the domain, the range, the values at points. Remember, we said that the y values can just be referred to as the values of x, or just be referred to as the values of the function at a point x. And we can also determine the intercepts. So here's an example. Using this graph, determine the following four questions. First of all, what is f of 0, f of 3 pi over 2, and f of 3 pi. Now, f of 0, which is right here, if you can read that, that would be equal to 4. F of 3 pi over 2, right here, that's at the x-axis, so that's equal to 0. And 3 pi, that's equal to -4. Now for number 2, the domain and the range. If you notice, there are no arrows telling it's continuing, so this is the entire graph. It does not keep going on and on. So the domain would be all the x values from 0 to, I think the rightmost one is 4 pi. And we can use brackets because those are closed dots, meaning the x values are included in that interval. If you notice, the range goes from -4 pi to +4 pi. And those y values are included, so we could just write the brackets. And before I get to number 3, I know I said from -4 pi to +4 pi. Ignore that, go with what I wrote from -4 to +4. Now, the intercepts. It's just, since it does not specify x or y intercepts, we're going to write both the x and y intercepts. The lone y intercept is at 0, 4. And the x intercepts are at pi over 2, 0. 3 pi over 2, 0. 5 pi over 2, 0. And at 7 pi over 2. Hold on, let me clear some room to write. 7 pi over 2, 0. And we use the squiggly brackets to denote a set of something. Now question 4, how many times does the line y over 2 intersect the graph? So if you notice, it intersects 1, 2, 3, 4 times. Alright, here's another example. Consider g of x equals x plus 1 over x plus 2. Determine the domain of G. The domain is equal to, you notice the only value that would make the denominator equal to 0 would be -2, because you would just set x plus 2 equal to 0, and then solve for x. So the domain would be all real numbers, such that x does not equal -2. Now for number 2, determine if the point 1/1/2 is on the graph. You can just plug 1 into here. Plug 1 into x. If you notice, then when you plug in 1, you actually get 2/3. So the answer is no. And question 3 should say, if x equals 2, then what is f of x? Or g of x, rather. So, to figure that out, you just plug in 2 into x, and you'll find that g of x is 3/4 when x is 2. Alright, here's the last example of this video. It's a 4-parter. First, find f of 0, f of 6, f of -6, and f of 11. And yes, I do know the numbers are kind of blurry, but we should still be able to do the problems just fine. First one, f of 0. Find, count up from 3. 1, 2, 3. You notice the y value is 3, so f of 0 is 3. Now, f of 6. Now we need to find where x is equal to 6. Count 1, 2, 3, 4, 5, 6. Notice f of 6 is equal to 0. Now we need to find -6. 1, 2, 3, 4, 5, 6. That would be this point here. It crosses the y-axis there, or it doesn't cross the y-axis. That would be the y value, and I believe that would be 1, 2, 3. -3. So, now f of 11. Now we know this point is 6, so why don't we just keep counting from there. 7, 8, 9, 10, 11. That looks like it'd be the point 11, 1. So f of 11 is equal to 1. Now the second question, determine if f of 3 is positive or negative, which means, is the y value associated with x equals 3 positive or negative? Well, if you look at the graph here, you notice it's positive. Now we need to figure out for what values of x, for number 3, is f of x equal to 0. Notice you only have 1, 2, 3 values of x. And those 3 values are -3, 6, and 10. If you count. So now for what values of x is f of x greater than 0? Of course, some room to write. Alright, so it's positive from here to here, from this x value to this one. So it'd be from -3 to +6. And we use the parentheses instead of the brackets because the values -3 and +6 would make it equal to 0, and we don't want those. That's why we use the parentheses. We can say union with, let me erase that and make it neater. Union with this little interval here from 10 to 11.